Very good afternoon, students. In the previous session, we have seen the ion exchange process and the reverse osmosis process. Those two are the purification methods. In the purification methods, we are removing the permanent hardness and the temporary hardness of given water sample. So, what is the use of ion exchange method? In the ion exchange method, the hardness causing ions are removing and we are getting the purified water. But whereas in the reverse osmosis process, it is the reverse process of osmosis. Osmosis is nothing but transfer of solvent particles from low concentration solution to high concentration solution. This is the natural phenomena, but whereas the reverse process, that is the reverse osmosis, is not the natural phenomena, it is one of the artificial phenomena by applying the external force. That means by applying the force by the human being, the reverse osmosis can be processed. So, in the reverse osmosis process, the solvent particles will transfer from higher concentration solution to lower concentration solution through semi-permeable membrane. So, that membrane is allowing only the solvent particles, it is not allowing the solute particles. So, like that we are converting sea water to pure water. That was the reverse osmosis process. So, now let us see the next topic, determination of alkalinity of water sample. So, before going to see determination of alkalinity of water sample, let us see what is meant by the alkalinity. It is also one of the laboratory experiment. It is part of our experiment. It is part of our syllabus in the chemistry lab. So, here alkalinity is nothing but basicity. You know what is mean by the basicity? So, just let us see what is mean by the base. Base is nothing but the solution whose pH value is more than 7, that is mean by the base, or the solution which contains OH minus ions is called base. But not only OH minus ions, remaining some ions are causing basicity to the water sample. So, what is mean by the alkalinity? Alkalinity is nothing but simply basicity. So, our water sample is having basic nature and the acidic nature, but which ions are causing the basic nature to the water sample? So, before that we know what ions are present in the hard water. So, what are the ions present in the hard water? Along with H plus and OH minus, it is having chloride ions, sulfate ions, bicarbonates and some carbonates and nitrate ions, and also calcium plus 2 and magnesium plus 2 ions. So, these are the ions present in the given hard water sample, but here only few ions are having the basic nature. Those ions are OH minus ions, bicarbonates and carbonates. These three ions are causes basicity to the water sample. Yes. So, now in our experiment we are going to find how much amount of OH minus alkalinity, bicarbonate alkalinity and carbonate alkalinity present in the given water sample. So, we are not finding individual alkalinity, that means how much amount of OH minus alkalinity, carbonate alkalinity and bicarbonate alkalinity, but we are going to find the total alkalinity and also we are going to find OH minus and carbonate, but we are not going to find bicarbonate alkalinity. That I will explain you later why we are not going to find the bicarbonate alkalinity. Yes. So, what are the three ions are causes alkalinity to the water sample? OH minus, carbonate and bicarbonate. So, these are the three ions causes alkalinity to the water sample. So, what is the aim of the experiment? Aim of the experiment is estimating total alkalinity of water sample and also finding OH minus and carbonate alkalinity in the given water sample. So, I said what is mean by the alkalinity. Alkalinity is nothing but basicity. So, it is also defined as acid neutralizing capacity. Acid neutralizing capacity. So, we know how the base is finding. In titration, the base is finding by using the titration with the acid. Same, we are finding the acid by titrating with the base solution. So, what we are going to find in this experiment? We are going to find the basicity of the given water sample. So, we know the basic nature is finding by titrating with the acid. So, it is going to neutralize the acid in the given water sample. So, here alkalinity is nothing but acid neutralizing capacity. So, how we are going to find the total alkalinity or OH minus and carbonate alkalinity? We are going to find the alkalinity by titrating with the acid. So, here the acid is hydrochloric acid. So, we are using 0.1 normal hydrochloric acid to find the alkalinity in the given water sample. That is the aim of the experiment. So, now let us see what are the chemicals required in the given experiment. So, now we know what is the aim of the experiment. Now, let us see the chemicals required. So, we know for chemicals required, which solution we are using for finding the basicity? We are using 0.1 normal hydrochloric acid, and along with that I am going to give the hard water sample to you. From that hard water sample only you are going to find the total alkalinity. So, what is the other chemical? Other chemical is the hard water sample. And one more chemical also there that we are not going to use in the theory, but in chemistry lab we are going to do the part A, part B and part C. But in our experiment in theory we are going to see only part C. We are not going to see part A and part B. So, I am not going to explain that procedure in theory. So, we are using only two chemicals in our theory experiment. One is the hard water sample and another one is the 0.1 normal hydrochloric acid. Yes. So, these are the two chemicals. So, the next is principle. So, I said how the basicity is finding by titrating with the acid. But what are the three ions are causes basicity? OH minus, carbonate and bicarbonate. So, what are the three ions? OH minus, carbonate and bicarbonate. But I told you now we can find OH minus and carbonate alkalinity, but we can't find bicarbonate alkalinity because in the given water sample all three ions are not existing together. These three ions are not existing together because OH minus and bicarbonate, these are highly reactive with each other. So, when OH minus is reacting with the bicarbonate, what happens here? The H plus in the bicarbonate and OH minus, these two are reacting to form water sample and it is producing the carbonate. That means when OH minus and bicarbonate, these two are existing in the water sample, these two are reacting with each other, and after reacting with each other we are getting the additional products, those are the water molecule and the carbonate. So, the three ions are not existing together. Any one ion is existing in the water sample or any two ions are existing in the water sample, but all three ions are not existing in the water sample. So, what is the possibility of ions present in the water sample? OH minus alone existing in the water sample, carbonate alone and bicarbonate alone existing in the water sample, and OH minus carbonate, carbonate bicarbonate. Yes. So, these combinations are possible in the water sample, but OH minus carbonate combination is not possible in the given water sample. Yes. So, those are the possibility of ions existing in the water sample. So, now let us see, let us assume in our water sample we are having OH minus and the carbonate. So, what are present here? OH minus and carbonate. So, now we know that in chemicals we need to add indicators also, because without indicators can we find the end point? We can't find the end point, because by using indicator only we can find the end point by color change. So, what are the indicators here? The indicators are phenolphthalein and methyl orange. Generally, in every experiment we are using only one indicator, but in this experiment we are going to find two indicators. One is the phenolphthalein and another one is the methyl orange. But what is the need of two indicators? Yes. So, why we are using two indicators in our experiment? Because phenolphthalein is finding only OH minus in the given water sample. It is not going to find the carbonate alkalinity in the given water sample. It is going to find only OH minus. So, let us take bicarbonate also. Sorry. So, phenolphthalein is going to find OH minus and carbonate, but it is not going to find the bicarbonate in the given water sample. So, what is the nature of phenolphthalein? It is going to find OH minus and carbonate, but whereas methyl orange is used to find all three ions in the given water sample. That means methyl orange is going to find OH minus, carbonate and bicarbonate, but whereas phenolphthalein, it is used to find OH minus and carbonate, but this carbonate also it is not finding completely. By using phenolphthalein, we can find the end point only half. We can't find the end point completely. So, here when OH minus is titrating with acid, when it is titrating with the acid, it is undergo complete neutralization. So, it is giving the end point, that is H2O. So, when carbonate, it is reacting with the acid, is it going to complete neutralize here? No, it is not complete neutralize here. It is neutralizing half and it is producing HCO3 minus. So, we know that minus 2 can react with plus 2 to get the neutral product, but here the minus 2 is reacting with plus 1. So, it is undergo half neutralization. So, by using phenolphthalein, these two reactions takes place. These two reactions are indicates, that means phenolphthalein end point is indicating complete neutralization of OH minus and half neutralization of carbonate. It is not neutralizing completely. But whereas when this bicarbonate, when carbonate is undergo incomplete neutralization, bicarbonate is producing here. But we know that by using methyl orange, we can't find the bicarbonate, because phenolphthalein is not going to find the bicarbonate, but whereas methyl orange can find the bicarbonate. So, here when it is undergo half neutralization, what is producing here? Bicarbonate is producing. But is bicarbonate is going to find by the phenolphthalein? No. So, phenolphthalein is not going to find bicarbonate. So, phenolphthalein is indicating complete neutralization of OH minus and half neutralization of carbonate. But when we use methyl orange indicator, all these three reactions takes place. That means even the bicarbonate also titrating with the acid and producing H2O plus carbon dioxide. H2O plus carbon dioxide. So, what methyl orange end point is indicating? It is indicating complete neutralization of OH minus and complete neutralization of carbonate and complete neutralization of bicarbonate. Yes. So, that is phenolphthalein end point and methyl orange end point. So, now let us see the principle again. Here in our solution is having the alkalinity. The alkalinity is determining by using 0.1 normal hydrochloric acid. So, here alkalinity is caused by OH minus, bicarbonate and carbonate. Here OH minus and carbonate are going to determine by using phenolphthalein, but all 3 ions are indicating by using methyl orange. So, if you want to find only total alkalinity, we can use only methyl orange. But when we are going to find only OH minus and carbonate, we are going to use phenolphthalein. Phenolphthalein is indicating complete neutralization of OH minus and half neutralization of carbonate. But whereas methyl orange end point is indicating complete neutralization of OH minus, complete neutralization of carbonate and complete neutralization of bicarbonate. So, here if the water sample is containing only OH minus and carbonate, that alkalinity is called caustic alkalinity. But when the alkalinity is due to the presence of all 3 ions, that is called permanent alkalinity. That means we are having 2 types of alkalinity, one is the caustic alkalinity and another one is a permanent alkalinity. Caustic alkalinity is due to the presence of OH minus and carbonate, but permanent alkalinity is due to the presence of OH minus, carbonate and bicarbonate in the given water sample. So, now let us see the procedure of the given experiment. So, what is the aim of the experiment? We are going to find OH minus, carbonate and bicarbonate, but we know that all 3 ions are not existing together. So, we are assuming that the given water sample is having OH minus and carbonate. Yes. So, I am going to give the water sample to you in the beaker. This is the water sample. So, this water sample is containing these 2 ions, that means OH minus and carbonate. But I said this alkalinity is finding by using hydrochloric acid. So, where we are going to use hydrochloric acid? We are filling the burette with hydrochloric acid, that is 0.1 normal hydrochloric acid. Yes. So, now let us pipette out 20 ml of water sample, that is the given water sample in the conical flask. So, first pipette out 20 ml of water sample in the clean conical flask. But we are using 2 indicators here. I said now, what is phenolphthalein indicating? Phenolphthalein is indicating complete neutralization of OH minus and only half neutralization of bicarbonate. But what methyl orange is indicating? OH minus, carbonate and bicarbonate. Yes. So, all 3 ions are finding by using methyl orange. But I want OH minus alkalinity separately, carbonate alkalinity separately. So, to find 2 alkalinities separately, I am using 2 indicators, that is phenolphthalein and methyl orange. So, initially which indicator we should use? We should use phenolphthalein because we need OH minus. If we use initially methyl orange, what happens? We can find the end point by using methyl orange only. So, we can't find the individual alkalinity by using methyl orange. So, initially which indicator we are using? We are using phenolphthalein. So, add 2 to 3 drops of phenolphthalein indicator in the given water sample. So, when we add phenolphthalein in the given water sample, it is converts to pink color because our water sample is having the basic nature. So, when we are adding phenolphthalein to the base, we will get the pink color. But when we are adding phenolphthalein to the acid, we will get the colorless. Yes. So, we are adding phenolphthalein to the water sample. So, immediately the solution is changing to pink color. Now, this pink color solution is titrating with the hydrochloric acid till color changes to colorless. Yes, note down the end point. So, what is the initial reading? 0. Now, assume the end point, that is the phenolphthalein end point X. So, what we are assuming? We are assuming phenolphthalein end point as X. Yes. So, we got one end point. What is that end point? Phenolphthalein end point. After getting colorless, to the same solution, add 2 to 3 drops of methyl orange indicator. So, when we add methyl orange indicator, we will get yellow color in the conical flask. Now, this yellow color solution is titrating with the same hydrochloric acid. So, we are not filling the burette till 0, we are continuing the titration from X. So, after getting yellow color, continue the titration in the conical flask till color changes to pink. Again we will get the pink color. So, now let us assume the end point is Y. So, here Y is the end point for methyl orange, but whereas X is the end point for phenolphthalein. But we know that phenolphthalein is indicating half neutralization of carbonate, but whereas OH minus is indicating, OH minus is completely neutralizing by using phenolphthalein indicator. Yes. So, now we need carbonate end point separately and OH minus end point separately. So, what here? We know P end point. What is the P end point? P end point is X. So, X is equals to OH minus plus half carbonate. But what methyl orange is indicating? It is indicating OH minus plus carbonate. Yes, but we need the methyl orange indicator separately, carbonate separately and OH minus separately. So, this is Y. So, if we do Y minus 2X, Y minus 2X, we will get carbonate. Yes, Y minus 2X, we will get the carbonate. So, OH minus end point is nothing but, carbonate end point is 2X and Y minus 2X is nothing but OH minus alkalinity. Yes. So, that is finding alkalinity by using hydrochloric acid, that is 0.1 hydrochloric acid. So, here by using the values also, that means by using phenolphthalein end point value and methyl orange end point value, we can find which alkalinity or which ions are present in the given water sample. So, those values are P is equals to 0, P is equals to M and P is equals to half M. So, we know what is P is equals to 0. P is equals to 0 is nothing but these ions are not present. That means OH minus ion is not present, carbonate is not present. That means which ion is present? Bicarbonate ions are present. So, that means only bicarbonate alkalinity. So, now P is equals to M. P is equals to M. P is equals to M is nothing but the P indicators and P end point, M end point is equal. So, P end point, M end point is equal is nothing but which ions are extra here? Here also bicarbonate ions are extra. So, bicarbonate alkalinity. So, P is equals to half M. That means P is equals to 2M. That means M is equals to 2P. So, M is equals to 2P is indicating, see here, so when we are multiplying this with 2, so what we will get here carbonate and here OH minus. See here we will not be having bicarbonate. So, what extra ions are present here? OH minus ions. So, when P is equals to half M, which alkalinity causes? OH minus alkalinity is causes. So based on these values also, we can find which alkalinity is present in the given water sample. So what is the aim of the experiment? The aim of the experiment is finding OH minus and carbonate alkalinity separately, or carbonate and bicarbonate alkalinity separately, by using phenolphthalein and methyl orange and by titrating with 0.1 normal hydrochloric acid. Yes, so this is the alkalinity of water sample or alkalinity of hard water sample. Thank you so much.